Hey guys, today I wanted to try and figure out, I wanted to check the voltages, which is the zener voltage of a zener diode. This says it's 8.2 volts. Now, if you've ever looked at a diode, a normal silicon diode will normally have markings on it that you can see. It'll have a number like I don't know, IN 4007, 4001, but it'll have a marking, and so you can look it up. These little zener diodes don't. So when you've got a couple out and you've been playing around with a few, then you go to put them back in their appropriate bags. You don't know whether it's a 8.2 volt or just a 2 volt. It could even be a 12 volt. That's hard to see on the back, but on there it does say 12 volt. Yep, 12 volts. This is even a 47 volt. Now this is going to test the capabilities of this power supply, and it will be the first time that I find myself putting it into the mode where I can have 0 to 60 volts from this power supply rather than 0 to 30 volts. See what else have we got here? We got a 30 volt zener as well. I've got a whole bag of them. I sent off with this mixed lot, and I sent absolutely lots. So in a way, some might say, well, yeah, you got that many zener diodes. If you don't know what they are, why don't you just throw them? Yeah, well, I can't do that. I have to figure out which ones they are and put them back in the appropriate bags. So I did have a couple out. It was an 18 volt one that I had out, but I just grabbed these off the top of the pile. And it was the 18 volt and the 12 volts that I was getting mixed up. So, but these are fine, because these go from like one extreme, 2 volt, up to 47 volt, with a couple of few in between. I think that's pretty good. That's a quite nice little range. The 47 volt one, which means I'll need to set up two lots of wires coming out and hook it together and get the system to track. So as I adjust one channel, it automatically adjusts the other channel, and then I use the combination of voltages. So if there's 10 on here and 10 on there, of course that's I've got 20 volts coming then. Now the trick is with these, after a little bit of reading and looking at a few videos on the internet, is that you can test the voltage and you can go over the voltage and you won't harm the diode as long as you set your milliamps very low. So I set up on both sides here, on both of these channels, to 10 milliamps, which really is probably, well, when we combine the two, it's going to be too much. 20 milliamps could kill the diode if I go up too high, but what we'll do is we'll see when the system is drawing. If I turn this one on, we'll see when it's drawing about 5 milliamp there and 5 milliamp here, the combination of 10 milliamp, and then we'll know that that's the zener voltage, that's the zener voltage of the diode, which is what we want to be able to find out to put them back in the bag. I've got this channel in first, channel 2. There's 3 channels on this. There you go, look, you can see the other channel there. This is a 5 volt channel. I'm not going to be using that just at the minute. It's just easier to see here, because it is nice to watch it going up in volts on there. I mean, it's fine, you can quickly add them up, that's not a big problem, but if you're checking out the 47, and you're looking at 23.5, it'd be so easy, so much easier just to look at it on there. So when it comes time for popping it in, I'll connect this across. When it's just the one side, when we're just going up to 30 volts, we'll just use one of the channels. Keep things simple. And of course, 2 volts up to 30 volts, one channel, and then when we bring in the 2 channels to go above 30 volts, we'll use this meter as well, just to give an indication of the one voltage not split across 2. Like that. Okay, let's get it going. Okay, so here we go. This is going to be the first diode. We're going to do the 2 volt one. I'll put that back there so I don't lose it. I'm literally I'm going to put the to the cathode side positive, as we're measuring reverse voltage on this, and what we got it set to, it's set at 1 volt anyway, so by rights, yeah, that should be okay. So I'm just going to turn that straight on. The overcurrent protection is on now. I mean, by rights this shouldn't be able to go higher than 10 millivolt, but just to ensure, I've put the overcurrent protection on. So what I'm going to do now is I'm going to dial up the voltage. As you can see, it's on milli there, so I'm going to just move it up a little bit just to get it going. So that's gone to 1.2, 1.3. This is a 2 volt, and what we're waiting to see is this. We're going to allow it to go up to 10 millivolt, and then that will be our, or whether it's just an indication, because now it's on 1.5 and we've got 1 milliamp. Let's search. And we're using 6 milliwatts as well. So that's 2 volts and we're on 0.4 milliamp. 2.1. So there we go. We got to the maximum output, and it cut us off automatically, which is good because we've protected our diode. So we know that diode is going to work for another day. Down here, I can see that it got to. If I move that across to there. And if I turn this back on, if I disconnect that now and just turn that back on, actually, we got to 2.3 volts before that went to 10 milliamps. So that's diode number 1. I don't know how accurate that is. I mean, I wonder if you could do it at 5 milliamps. Maybe I need to learn a bit more about the details. I just wanted the way to test the diodes and to figure out, you know, which bag they were going to go into, basically. Maybe I take an 8.2. Have we got anything between that? We got a 12 volt, we got a 47 volt, and there's a what we got here? We got 30 volt. So let's get rid of the 8.2 and we go straight to the 12 volt, because this would be quite a common one to use. And if you're building your own ZVS drivers, ZVS zero voltage switching, which is, that's a great thing, isn't it, being able to switch on 0 volts. So same again, we're going to connect positive to the cathode. Where is that? Negative. I'm going to pop that on there, and this is still on. It's at 2.3 now, as you can see. We're not drawing any ampage, it's not drawing any wattage, so let's click it back to voltage, put on the right one. So across here, we're going to just take that up I'm going to use this a little bit quicker on this thumb wheel and just go. No, if I go back, did you notice? It just seemed like the ampage went to 1 milliamp light there. I don't know what that is, I don't know if that's the power supply or... Okay. And this was, what was this? This was supposed to be... Oh, 12 volts, isn't it? I'm looking at the bag behind me now. 8.2. So we're on 10. Now remember, even if I were to shoot this up to 20 volts now, it made no difference, it would just cut out. It would just cut out. So there we go, we're on 12 volts. Just over 12 volts looking at this drawing. Now I wonder if that's really, as soon as you start drawing power, because there, and then just flicking it there, I mean that is almost perfect. That would say that this diode because now there's current going across this circuit. Up until 12 volts there was nothing. Now we're on 12 volts and this is a 12 volt zener diode. As soon as you go above 12 volt threshold, now we've got current being used. I'm going to hedge a guess here and say that that is a better measurement of this diode. We're going to see, because we're going to try another diode and see how close that is, and as soon as it moves the mark here, if that's on the correct voltage rather than it going above it, like on the 2.3 it got to before that did, but that's because I was trying to go up to 10 milliamp. I wonder if it is better, just as soon as you start seeing the circuit being made and current passing, that's got to its threshold. And then going up, that would just, you know, I think they call it an avalanche diode as well, avalanche it, so. Okay, let's just turn that off for a second, and we're going to pop that back in its bag, because we know it's a 12 volt, pretty damn accurate if the way I'm looking at that's going to be correct. So let's go for what we got here. We got 30 and 47. Hey, let's try that 2 volt again. We're on voltage on here, so let's just go down to 1.1. Just dial it in; it's a lot quicker. 1.1, and then come here. I'm gonna a bit fiddly. So put the 2 volts there. Positive to the cathode again. Right, so let's turn that on. So this is the 2, it says 2 volts on there, so I'm going to wait, and if that just goes you know, one little part, 3, 6, 2, and now we're doing, hey, look, so 1.7, and we got 1 milliamp, and at 2 volts we got 4. So let's try the, we did the 12, the 2. Well, let's try this 8.2 then, because 8.2, I mean, that's dropped it. 8.2 is pretty specific. So you think 8.2 then, that this should be pretty specific on here. It's not going to be this is probably, hopefully, will be the closest one claiming to be so specific. Was it? Why I didn't mark these up? These were already pre-marked up when I bought them. So I did not mark them up. Get on there. A little bit of black as a marker pen, because I can't seem to draw without drawing over myself. So there we go, we got an 8.2 now, so let's turn that back on. We're gonna whiz this up. There's a little bit of lag on that, which is a little bit disappointing. So right, now we're starting to get into a critical area. So 7.5, look, and we got 1 milliamp. let's get it to 7.9, 8.1, 8.2 it was, wasn't it? So, you know, I'm going to say that this isn't particularly too inaccurate. So 8.2 volts, and we've got ourselves some current draw. So the other one was bang on, the other one was 8.5, 1 milliamp, sorry, 5 milliamp, 3 milliamp. Let's see what we do at the higher scale then. Maybe 10 milliamp is the scale that had been used to demonstrate one of the videos I watched, because that was their resolution. That was all they could do on the resolution. I got the upgrade pack for this. Wink, nudge, nudge. If you go and look at my other videos, you'll see there's the upgrade. Come here. What's this? This is okay. This is 30 volts. So then we're going to get into the threshold of what this power supply can do in this configuration. So let's pop this on. 30 volts. So I'm going to wind this up. Just key it into 28. Yeah, we're on voltage, so I can just go 28. I can put 28.2 if I want to. There we go. Oh, we're probably better off turning it on. We need to go down a little bit then. I don't think it likes the shock. So let's go to 10 and just wind it up from there. No, it doesn't like that. No, have I got this the wrong way around? I don't think so. I don't think so, I don't think so. We're still on 10 milliamp. We've got over current protection on, which is if I turn that off. Okay, I've turned the over current protection off now. It's still set at 10 volt and 10 milliamps. So I'm going to see what happens. So what was all that about? Now what happens if we do go over? So I'm going to go back to 28 volt. Because this is supposed to be 30 volts, isn't it? Yeah. Oh, okay. The overcurrent. I wish it was staying a little bit longer. So let's just wind it up from here anyway then. We can wind it up like that. We can also wind it up like this. Just going down a bit to where it said 1 and 14. Maybe there's some sort of like little glitchy bit with. But this should be able to go up a little bit quicker. Now we're coming into the area. 27. Okay. So and there's our 30 volts. 0.090 watts. Remember I set this to 10 milliamp. So at 5 milliamps. I need to look at the data sheets. Well, I don't suppose I have actually any data sheets for these. Just look up generic zener diodes, can't I? I'm just wondering, you know, about that. But anyway, so you know we can safely say that that's starting to draw current now. We're getting current move across. So we got our 30 volts. I think I'm doing this right. I don't know. I could be doing it actually wrong. I don't think I am. I'm just trying to get closer to accurate measurement of what should be what. There's a slight variation throughout the whole lot, but it is only a milliamp or so, isn't it? So, which is pretty good. Right, now the next bit's the best one. 30 volts. Oh look, and the bag's got a hole, that's going to come in handy. So I've got two holes, one permanently open, the bit sticking out, so I'll probably need to find out another bag for that. See, another thing is if these started coming out of the bags, because these are pretty thin bags, if they did start coming out of the bags, at least I could do this to find out which one it is and which one it isn't. So now what we got left, we got this 47 volt one, haven't we? So okay, we need some more leads. We need to put two leads in here, obviously, red and black, and then we're going to tie this red and this black one together, and then we're going to track. We're going to hit the tracking, so we have whatever I do on this will happen here too, and then we just combine. So we've got 20 here, we've got 20 there, that means 40 volts in total. And we're also going to use these probes on this in order so we can actually see it going up in the voltage there too. That's the true voltage. So couple of leads, pop that in there, pop that in there. Rub that in there. I'm just going to put these together just like that and tuck it inside itself just to keep that nice and neat and out of the way, even though it's kind of just unroll now. And yeah, just put the slime back. Right, so we can just chuck it down there. Will you stay out of the way, please? Thank you. Okay, and now how are we going to do this? We're going to get our thing here, and we're going to tell this to track. So we turn the tracking on. Now they're both on 30 volts, so that's 60 volts we got there. And let's just check to see if we have or haven't. We don't want to put that on, do we? Because that's not gonna, oops, come here, it's not going to get us anywhere. If I turn that on, here we go, 60.03 volts, 60 volts. So we don't want that high. So let's just put that on there, and this was 47 volts, wasn't it? So we're going to go down to 12 here, and that'll be 24 volts. Does that actually work? No, we're going to put it onto the right thing, that's why. Okay, 24 volts. That might still be a little bit too high, but we're going to see. Now, the way I'm going to do this is I'm just going to shove that probe inside there. I'm going to shove that probe inside, no, not inside the jaws. I want the jaws for the diode. There we go. And then I can just put the diode inside the jaws. I could if I could find the diode. I dropped them. I didn't eat them, did I? I'm getting a bit peckish. Yeah. What did I do with it? Is that it? 47 volts. There we go. So let's take this out of here. Right, the same way. If I just turn that off now, I just want to do this. Let's just pop that in there. Actually, I wonder if I can just stick it down there as well. I am going to try and get it inside the jaws, but I'm not going to be that fussed if it's not. I know it's there, and we can all see it in there, can't we? So let's just turn that on. Okay. I think that was my connection I had with it, that's why that took so long. So let's start spinning it up anyway. Let's just set that so we can do it one at a time. 24, so we want to go to 47, so I put it straight onto, let's say 40. 40. Didn't like it. It says the upper limit of 32. I don't know why it's saying that. That's because I've got tracking on. Yeah, tracking's on. So, 32. Anyway, let's do it like this instead. So we've got 35 volts coming out. Okay, so in total over here we're on 45 volts, and this is a 47 volt zener. 2 milliamp. No, not quite 2 milliamp yet. We got 46.7, 2 milliamp, 47. And that's going up. 4 milliamp. Well, I suppose that is, because if we looked at it like that, that is 4 milliamp basically. So if we sat around about the 3 milliamp, you got to remember that these are two combined. Oops, two combined. So that is 4 milliamp. Dropping between 3 and 4. So I've not got the connection in properly, have I? There we go. So there we go. So that's how we test. That's how I've learned very recently how to test the zener diodes, which always have me baffled. Brilliante. Oh, if you got this far, thanks for watching, and yeah, bye y'all.